All right, happy Tuesday of week 2. You guys made it through the first week. Woohoo! I'm so happy y'all are here. I'm so happy to see everyone. Um, so tonight might be a little bit longer. The reason I would have loved to have like stopped halfway through 3.4 or stop at the end of 3.4 actually, and then do 3.5 and chapter 4 on Thursday. But 3.4, 3.5 are a homework assignment together. They're squished together. And so it's going to be a little bit longer today, and then Thursday should be shorter. And then Tuesday is going to be I debated on this because summer term is short. I debated having office hours, but office hours has been so useful and helpful in the past. So next Tuesday, there will be no new material presented. Instead, it's a drop-in office hours. So you can get homework help. You can ask questions on the test review, any other things you need clarified. It's just going to be a drop-in office hours. So you can show up, ask your questions, and then leave, or you could not show up if you don't need to. The test opens on Tuesday morning at 5 a.m., and then it closes on Thursday. This is next week. Closes Thursday at midnight or 11:59. So Tuesday, always on opening day of the test, I do an office hours. So you can drop in or not drop in or whatever. And I can help you out with whatever you need. So today we're going to do sections 3.2, 3.4, and 3.5. We're going to talk about the range of raw data, which will take all of 30 seconds. We're going to talk about standard deviation. So I'm going to show you how to calculate standard deviation by hand. It is a bit crazy and like a very long process. But then after that, I will show you a fancy schmancy calculator function that will do it for you. And it's going to show you a lot of different things. It's super helpful calculator function. So this will be probably one of the things you use most in your calculator, what I'm going to show you today. And then we're going to talk about the empirical rule. So the empirical rule is one of those things that um, most people pick it up really quickly, but for some reason, about 10 to 15% of the people, maybe even a little bit more than that, there's a disconnect there and it's really hard to wrap your brain around. And it's probably because it's a little bit abstract. So I'm going to do my best, but please, if you have questions, ask them either during class or when you're starting to do your homework. Make sure if you are getting stuck, you ask questions. Because the empirical rule is super important and we're going to be using it a lot throughout the term. So if you don't grasp it right away, don't kick yourself, ask questions.
It
And
seems like
what was
this
that?
goes. It seems like this goes along with my science class a little bit because we just went over the empirical rule today in class. So
Stats and science do that a lot. So
yeah.
you probably already know a little bit about it. So that's awesome. And real quick, also, I'm going to show you in in Blackboard. So it's weird things happened here. So in the Zoom tutoring is now been moved and it is now in Blackboard instead of going through the RCC website. So if you are in the assignments and lessons page, I thought I added that. So this document right here, there's a PDF, Zoom tutoring summer change. If you open it up, it gives you instructions on how to get to it. So it is right there. So we've got some really great tutors this term. Use them. They are so helpful. They're really amazing. So this is where it says to click on institution page, and I guess you scroll down and see the online tutoring right there. So it is super helpful. We have great 243 tutors. Get out of that screen and go back to where I was. All right. So section 3.4, we're going to talk about what z-scores are. We will interpret them. Z-scores are also super important. We're going to talk about quartiles, talk about interquartile range. We're going to talk about outliers, 5-number summaries. We're going to draw some box plots, and then we're going to go over lab 2. Lab 2 only works in Excel. Just letting you know. So Google Sheets, it works, but you have to actually, it's a paid add-on. So you have to buy a paid extension in order for it to work in Google Sheets. There might be another workaround. I don't know what it is, but since Excel is required and it is free through the college, use Excel. I will mark you down if you don't use Excel. So use Excel. Excel is your friend. I will show you two different ways to get the tool on Excel that we need. And I have a PC and I have a Mac, and it is different on both my computers, and I don't know why, but I'll show you both ways. Hopefully your computer, whatever you're using, has one or the other of those. All right. So we're going to get going, and some of this will be super fast. Some of it will take a little bit of time. Hopefully you'll pick it up and run with it and do awesome. And if we need to, we'll take a little break in the middle. But let me tell you, Thursday's class, probably 45 minutes of lecture and then a really quick lab. So it'll be pretty fast. All right. So let's talk about, this is 3.2. Let's talk about range from raw data. All range is the largest data value minus the smallest data value. That's all it is. It tells you the difference between the top and the bottom. So take your largest data value, subtract your smallest, and that tells you the range. That is really it. That's all there is to it. See, all of 30 seconds. And now there's no rain at all. Stopped completely. That was quick. Medford, I hope it's heading to you. All right. So we're just going to use, this is the travel times for the 7 startup employees of the Startup Web Development Company. We looked at them last week, and we're just going to find the range. So our longest commute is 43 minutes. Our shortest commute is 5 minutes. So we just take the 43 minus the 5, and our range is 38 minutes. That's it. That is all of the math right there. Okay. Let's talk about standard deviation. So standard deviation, so the simplified way of talking about it is it tells you how spread out the numbers in your data set are. So the little bit more complicated, but not the super complicated, so the middle of the road, it tells you the average distance each data value is from the mean. So we take the average distance the data values are from the mean, and that's the standard deviation. A larger standard deviation says that things are more spread out, therefore that average distance is more spread out. A smaller standard deviation means things are grouped more right around the mean, right around the center of your data, and therefore you have that small standard deviation. So it is a little bit complicated how you calculate it, but as I said, I'm going to show you how to do it in the calculator. I think that there might be a question or two that requires you to break it down a little bit more. So we are going to do it step by step, and I'll show you how to calculate it by hand. So this symbol right here is the lowercase sigma. See, this one is an uppercase sigma. This one is a lowercase sigma. So the lowercase sigma is what we use for standard deviation, only for the population standard deviation. So if I'm finding the standard deviation of the entire population, I use the Greek symbol sigma. And what this is telling me, you take each data value, subtract the mean from it, then square what you get. So every data value, you subtract the mean from it, then you square it. Basically, what we're doing by squaring it is we're getting rid of any negatives, because some of them will be negatives. So we're just taking it, subtracting, and then square it. Then you add all of those squares together. So all of the things that we just squared, we add them all together, and then divide by the number of observations. So however many data values we have, that's what we divide by. Once we do that, take the square root of everything you just, of what you have. You take the square root of your result. That gives you your population standard deviation. Don't worry, we're going to math it out and you will see. So it looks big and complicated. It's really not that complicated. It's just very tedious.
So,
Yes.
um, so excuse me, should we write this down then?
So since this is your first time joining the class, I highly recommend before class printing out the, yes, I would write down the formula, yes. But I
Okay.
recommend before class print off print off the PowerPoints that I have in the weekly folders and print
Okay.
them like two or three to a page, and then you could take notes directly on it. It's going to help you a lot.
Okay. That makes sense. Okay.
But yes, write this down for sure. So next class, Thursday, if you do that, you're going to notice it's going to be a lot easier. Plus, you can use the notes, those PowerPoints, after you've taken notes on them, you can use them on the test. So if you wanted to go to last week's classes, I don't know if you've watched those Zooms yet, but if you want to print them off and then take notes through those Zoom recordings, then that's going to be notes that you've created that you can use on the test.
Okay, cool.
Yeah.
That would be super helpful.
Yeah. Especially since there's a lot of data sets and graphs and things like that, and it makes it much easier if you can just write directly on them. All right, moving on to the next slide. Or you need a second?
Nope, you're good.
Okay, maybe next slide. Okay. All right, so we're going to find the population standard deviation of our travel times. So the first thing I'm going to do is find the population mean. I don't remember what that is from last week. I'm lucky if I remember my grandkids' names. Today was a crazy day. Okay, divided by 7, 24.9. So our mean, whew, that was weird. Our mean, our mu, is about 24.9. So this is what we're going to use for our mean. And I'm going to make my pen just slightly smaller because for some reason it's writing really fat. Okay. So now I'm going to take each data value. I'm going to subtract the mean from it and then square it. So I'm going to do 23 minus 24.9 squared. Well, that's not the right thing. So this is 3.61. We're going to do this on each of them. So 36 minus 24.9 squared. 123.21. Thankfully, this is a repeat value. Uh-oh, that's a log. We don't want that. Okay. So just imagine if you had a data set that was like 30 numbers long. This would not be fun.
So you have to do this with every single number?
Every single number. Don't
Wow.
worry, you're going to get a calculator function here pretty soon.
All right.
Okay. So I took each data value, subtracted the mean from it, and then squared it. Okay. So now we're going to add all of these values together and then divide by 7, which is the number of data values we have. So I'm going to add all of these together. That's 9, unless I did it wrong, it's 9. Uh-oh. 923. That's not where it goes. Nah, having issues. If anybody's doing this math along with me, please tell me if I erred. I did err. I did err. This is not right. I instead of a decimal, I hit a plus. Doggone it. There we go. Don't trust me with a calculator, apparently. There we go. Hopefully this is right. 902.87. That sounds better. Okay. Then divide that by 7. I have 128.98. All right. So now that I have divided by 7, take the square root of this number. So my standard deviation, my sigma, is approximately 11.4. So what this is telling me is that the average distance, each of these data values is from the mean, is 11.4 miles or minutes times. So we have an average of 11.4 minutes distance from that 24.9. So that's what the standard deviation tells us. And 11.4, considering our mean is 24.9, 11.4 is a pretty big standard deviation. So this is telling me that they're pretty spread out. And we can see that because, I mean, I have a 5 and I have a 43. So these definitely spread out a little bit. Questions on population standard deviation?
So I have a quick question.
Yes.
So this is this is how we this is how we calculate the 1 unit movement like on a graph, right? So this is like I don't know how to frame my question. I'll think about this and try to rephrase it later.
Okay, no problem. So yeah, this is just, so the mean is this obviously the average of all of them, and then the standard deviation says each value has an average of 11.4 minutes from the mean. So you will see we're going to use standard deviation for a lot of things coming up. So hopefully it becomes more clear. So let's go to a different data set and let's get our standard deviation. So I'm going to pop over here. Okay. So before we get into this, I want to discuss the difference between deviation and standard deviation. A deviation is just a difference from the mean, and it could be any difference. So once I do, our test score, our average test score, I remember this one, our mu was 79. So I do 82 minus 79. So that equals 3. So that's a deviation. That's a distance from the mean, but it is not a standard deviation. Standard deviation is that average distance from the mean. So it is completely different than a deviation. So
That
when,
answered my question. That
okay,
answered, yeah, that was
yes.
perfect.
So standard deviation is the term we want to use because it's standardized. It's an average. Whereas each data value deviates from the mean by a certain amount, but the standard deviation is what we're calculating here. So I'm not going to calculate all of these because we're going to put these in our calculator, but I'm going to do a few of them because I just squared the 3. We're just going to do a few of them. 77 minus 79 equals -2, which gives me 4. So you would do this with each value. So you would do this with each value all the way down. I'm going to give you a way that to do this in the calculator. So get out your fancy calculator. Hopefully you all have them handy. Get out your fancy schmancy. And every single one, TI-83, TI-84, doesn't matter if you have the fancy CE like I have, or if you have a plus or an extra or whatever they're called, all of them have this function that we're going to use. So I'm going to pop over to my calculator. Let's pop over there. All right. So we should all be right here in our calculator. You might want to write down these steps. So I'm going to hit the stat button. So the stat button is right here. I need to go to my other screen because I have the data set on my other screen. I think I have the data set on my other screen. I do, because I want to be able to see it. Okay. So hit the stat button, and then you want the first option, which is edit. So hit enter, and it'll bring up this screen right here. We will, Natalie, I'm going to get to the sample data in a minute. So we will be doing sample, but we calculate it slightly different. And so I'm going to show you how we do that in a minute. Okay. So if you have data in your list, like right here, so notice my L1, which is what we're going to be using. That's list one. I have data in there right now. So I'm going to arrow up and I want to highlight the L1. Then I'm going to hit clear, enter, and it clears the whole thing. Do not hit delete. Hit clear, enter. So just highlight, arrow up, use these little arrows, arrow up to highlight L1, then hit clear, enter, and everything will go away. If you hit delete, you're going to be really sad because your entire L1 list will disappear and you'll be really sad. And then you'll say, Melissa, I lost my list. Can you help me? And then I will help you because I know how to get it back. But clear, enter. All right. Now you just start entering your values. I'm going to put in 82, enter. You just put the value in and then hit enter and it'll go to the next spot. So I'm just entering all 10 of these data values. My most common error is typos in my data. I do it frequently. I am the typo queen when it comes to entering data. I'm going to give you a second to catch up if you don't have it, the data set right in front of you.
Where did the 79 come from?
Did I put 79 is our mean.
Okay, okay.
Yeah.
Thank you.
Yes, no problem. Okay. Does anyone need another moment?
I do.
Okay, I'll give you another moment.
Thanks.
Problem. No problem. Let me know when you're good.
I'm good, but what's the 79 that she was talking about? I don't see that.
It's not there. It's on my, it's on my, right here. Our mean,
Oh.
our mean is 79. Yes.
Good. I thought I missed something.
No, you're good. All right. Anyone need another moment? Okay. I'm going to hit the stat button again. Stats right here. And then you use the arrows to arrow over to calc. I want to highlight calc. And use the first option right there. So I'm going to do it again. Stat, arrow over to calc, and you want the first option. So hit enter on the first option. I'm going to pretend my list doesn't say L1 right now. Delete it. And you want your list to be L1. The way to get L1 in there is to do second and then the number one, and that'll put L1 in there. Like for example, sometimes you're working with more than one data set and you'll put one data set in L1, put another one in L2, another one in L3, and you keep going. And so if my data was in L3, then I could do second 3, and then I could use the L3 list instead. But we're using the L1 right now. We're leaving frequency list, this right here, we're leaving that blank. And then you're going to go down to calculate and hit enter.
I didn't get that screen. When I hit the first option, it says one dash bar stats, but it's like out of that screen.
You probably just need to put in L1 there. Can you just
it doesn't show list, frequent list, or calculate. Yeah. It actually brought me back to my previous screen. Not previous, I'm sorry, the original screen with like previous calculations on it.
So when it shows you one var stats right there, can you just will it let you just put L1 after the one var stats and then hit enter?
Can I show you on the camera what it looks like? I'm having a hard time describing.
Okay. Let me change. I think I need to change my settings to allow you to share.
Oh, okay.
Or you can just put your camera up. Okay, yeah, show me.
That's what happened.
Okay, now put L1, do second one right now.
Okay, second one.
And then hit enter.
Oh, now it says L1. Okay.
Yeah. Did it get you good?
Yes,
that right? That's where, yes.
Okay, thank
Yay.
you.
No problem. Okay. There we go. Does anyone need a second, or are we all on the screen? I'm not going to show you what every option is yet because we haven't learned everything yet, but I'm going to show you a few things. This first one right here, this X bar, as I think I mentioned it last week, that your calculator just automatically assumes we always have a sample. So it's always going to give you X bar, but that's okay because mean is calculated the same way, whether it's a sample or a population. So X bar is fine, even if though this is our mu, no big deal. The second one, the second thing right here, this is just, they just added up everything. They added all our data values together. And I don't know why they do it, but they added all our data values together and they squared them. I've never needed that, but hey, cool. I'm going to skip the next one. This one right here, the sigma x. This is our standard deviation, our population standard deviation. So in your calculator, it says sigma x, 9.8 is our population standard
Sorry
deviation.
to interrupt you. The screen isn't shared anymore.
Oh,
Your beautiful face instead.
Oh. Geez. Sorry about that. Okay. Thank you. Thank you. Okay, there we go. Okay, so I'll go over them again. I appreciate that. Okay.
Thank you, Natalie.
Right, once again, so our X bar is 790. This second one right here is the sum of everything. The sum of everything squared, have no idea why it's there. Sigma X right here, this is what we're looking at. The 9.8, that is our standard deviation. So the average distance every value is from 0 or from the mean is 9.8 approximately. And this right here tells us that we have 10 data values. I'm going to stop there because the rest of it we're going to learn later. So I'm going to stop there. Any questions on this screen so far?
So when you say 10 is our unit or is our value, that's rounding up from 9.8, correct?
No, the 10, it tells us how many data values we have. That's
Oh,
what 10
okay.
is.
I see,
That
I
we have,
see.
yeah, 10 data values. That's what that is. All right.
Okay, yeah, I understand. I understand.
Yay. All right. Okay. I am going to pop back over here. I wrote down that sigma is 9.8 and there we go. So now we have our mean and our standard deviation. Standard deviation will be important later and you will know exactly why we need that and how it is useful. So there we go. All right. So let's talk about, let's talk about sample standard deviation. So the thing with standard deviation is standard deviation is not resistant to outliers. Standard deviation can get dragged significantly by outliers. Also, if I took a lot of different samples, every single one of the standard deviations of those samples is going to be different. In order to account for the variability of the different samples, we need to have our standard deviation be a little bit larger for a sample to kind of encompass more and to take into consideration that error. Therefore, instead of dividing by the number of data values we have, I'm going to use a highlighter instead. We divide by 1 minus the number of data values we have. We call this degrees of freedom. Don't worry about what that means. Just go with it. So we use the symbol S instead of sigma when we're using sample standard deviation. So we're going to use the symbol S. And the only difference is you divide by n minus 1 instead of n. I'll give you a second, those of you writing it down. And I'm so sad that it's not raining anymore. It did not rain nearly long enough. Right. Okay, move into the next screen unless anyone needs more time.
I need a little bit more time.
No problem. I'll give you a moment.
Thank you.
You're welcome.
So the only difference is you just subtract the n minus 1 and then complete
So
the equation as normal?
instead of dividing by n, because our last one, I divided by the number because we had 7 data values. I divided by 7. Back here, we divide by n. Over here, we divide by n minus 1. So Like for example, here, if I was doing it, if it was a sample, I would divide by 6 instead of 7. Here, instead of dividing by 10, I'd divide by 9.
Oh, 9. Okay, I see. I understand. Okay, okay.
Yeah.
I'm almost done. Sorry.
No, you're fine. It's okay.
Is there any time that we would ever divide by n-2 or n-3 or so on and so forth?
Nope, just n minus 1.
Okay, thank you.
Good question, though. That was a good one.
I'm good to go.
Oh, sorry.
Go ahead.
My apologies if you're going to explain this, but why are we doing n-1 for the sample?
Because there's because there's so much variability in different samples, because we saw it when we were taking sample means that every one of them was different. Because there's a lot of differences, we could have not chosen a super small value or not chosen a super large value. So in order to account for that variability of all the different samples, we're kind of we're making our standard deviation a little bit bigger. So we're dividing by a smaller number to kind of account for all that variability.
Thank you.
You're welcome. All right. So we're gonna do a practice. So here we're gonna find the sample standard deviation of these 3 data values. Thank goodness it's a small one. So we're doing exactly the same thing we did before up to the point where we divide. So I'm going to take our average of these 3 things. I need to figure out what my X bar is, because remember, X bar is the average of a sample. So my X bar is approximately 22.3. So I'm going to use that average. So I'm going to do 5 minus 22.3 and square it. That's big. 299.29. 5 minus 26, square it. Oh, that's wrong. I'm having issues. Just a second. 26 minus 22.3. I don't know where my brain is today. 3.7. Got to square that. 13.69. And 36 minus 22.3. And square that. 187.69. Okay. So that's a really ugly 9. I'm going to fix that. So I took each data value, subtracted the mean, and now I'm going to add, and then squared them. I'm going to add all of these together. Took all of these, added those together, 500.67. So now we're going to take 500.67 and we're going to divide it by 2 because 2 is n minus 1. If it helps you for your notes, you can do 3 minus 1. If that helps you to show that in your notes, just so that you're knowing that that's n minus 1. Okay. Now take the square root of that answer. I'm going to take the square root of 250.335. So that is 15.8 approximately. So my sample standard deviation, it's a lowercase s, but it's really hard to tell the difference between a lowercase and an uppercase. So just trust me, it's a lowercase s. So my sample standard deviation is 15.8. So it's calculated just the same way, except for we're dividing by n minus 1. Give you a second to write that down, then we're going to pop back over to the calculator. All right. Does anyone need another moment? Questions on this before I move on?
Oh, sorry. I need just like another half second here.
Okay, no problem.
All right, I'm good to go.
All right. I'm going to pop back over to the calculator. Maybe if I can find it. All right. So now that we've calculated a sample standard deviation, I will tell you this SX right here is sample standard deviation. So the sigma X is your population standard deviation. SX is sample standard deviation. I highly recommend writing those down.
So, okay,
Could
so
you repeat that
SF,
one more time? I'm sorry.
Okay, no problem. Sigma X right here is your population standard deviation. SX is your sample standard deviation. It could help to remember that your sample standard deviation is always going to be larger than your population. It's always going to be bigger, and so that should be helpful if you can't remember which is which. But usually population gets a fancy symbol and sample gets stuck with a letter. Like we have X bar for sample and we get mu for population. And then we have S for sample and a nice cool sigma for population. Population always gets the cool symbols. All right, I'm gonna move on. Get back over here. Weird things happening. Okay. So let's talk about, let's compare some standard deviations and talk about the implications. So we're going to take a look at some data values and we're not going to calculate anything. I'll calculate it for you. We're going to compare their standard deviations. So I have a bunch of wait times right here. These are samples of wait times at Wendy's and wait times at McDonald's. Right now, it's just a whole bunch of raw data. It doesn't tell us anything. It's just a bunch of raw data. So our standard deviation, sample standard deviation for Wendy's is 0.738 minutes. Sample standard deviation for McDonald's is 1.265 minutes. So the McDonald's data is more dispersed. So it is like our range is probably bigger. So it is more spread out. It means that it is less consistent. So this doesn't tell us which one has longer wait times. It just tells us which one is more consistent, which one stays closer to the mean. So Wendy's looks more consistent. So even if their wait times are longer, you can probably predict a little bit more accurately what your wait time would be at Wendy's rather than what your wait time would be at McDonald's. McDonald's has considering most fast food restaurants, they don't want waits to be any more than like 2 or 3 minutes. So if you have a standard deviation of like 1.25 minutes, that's pretty big. That's telling you that you're pretty spread out because the average distance, the values are from the mean, is about 1.25 minutes. So I mean, that's significant in the land of fast food. Wendy's is not too bad at all. It's like 3/4 of a minute is their standard deviation. So as far as consistency goes, Wendy's is more consistent. It's more predictable, more reliable, whereas McDonald's is a little bit less predictable. Questions there? Right. So this is something I have never in my life ever used for anything, but it is something that for some reason it is frequently asked in things like homework. I will not test you on it, but the variance is just the standard deviation squared. So you just take the standard deviation and you square it, or it's the value before you take the square root. I've never seen a sample variance asked on a test on a homework assignment, but population variance on assignments is asked occasionally. So all it is just the standard deviation squared. That's all the variance is. I don't know what it's good for. I've never used it for anything, but there it is. It has its name. It has a name. So just write it down. Variance is standard deviation squared. Because I think maybe 1 or 2 homework assignments ask you that question. All right. Moving on. All right. So this is a very, very important piece that we're going to jump into. And I'm going to give you a diagram that you are going to probably be writing over and over and over again. You will draw it numerous times. Hopefully you'll draw it enough that you will have it memorized, but you can use it on your tests and quizzes, or there's no quizzes in this class, but you can use it on your test. Therefore, you're going to want a copy of the diagram. All right. So approximately 68% of our data is within 1 standard deviation of the mean. So if I take the mean and I add the standard deviation to it, and then I subtract the standard deviation from it, it's about 68% of our data is going to lie between those 2 data values. About 95% of your data is within 2 standard deviations of the mean. So if I add the standard deviation twice and I subtract the standard deviation twice, within those 2 values, about 95% of your data will be there. So letting you know, anything outside of 2 standard deviations from the mean is an outlier. So I'm going to write it down. Oh, that is a highlighter. We are not going to write it that way. Anything. I'm going to say this over and over again. You will hear this from me 25 times. So more than 2 standard. That's my abbreviation for standard deviations. Man, my handwriting's really bad tonight. Sorry. From the mean is an outlier. I'm going to give you a second to write that down. This is important.
That includes both sides, right?
Yes.
So plus or minus.
Exactly. So 2 above or 2 below. So anything that is more than 2 standard deviations above or below the mean is considered an outlier. So if you had sample data, I would use X bar instead of mu, and I would use S instead of sigma, but you guys get the idea. So most of the time we have sample data anyway. So, but just letting you know, give you all a moment and then we will move on.
I've got a question.
Yes.
So I went ahead and jumped ahead and did my lab 2. And your question 2 says, are there any outliers on there or z-scores? So if the mean is already calculated, are we able to just look at those numbers without having to do any math and be like, okay, these numbers are outliers and these numbers are outliers?
No, you have to show me the math to get there,
Okay.
or tell me what, about the z-scores. I think it specifically mentions to the z-scores. For the rest of you, I haven't done z-scores yet, so don't worry, we're going to do those tonight. But no, you have to reference the z-scores.
Okay. Thank you.
No problem. All right, moving on. So this is the diagram that you are going to want to keep on hand. This right here is super helpful. So as I said, 68% of our data is within 1 standard deviation of the mean. So therefore, 68% of my data is in here. Approximately. It's not exactly, but it is approximately. So these spots right here, this right here, this right there, and this right here, it adds 13.5% on either side of those, that 68%, which adds up to 95. So 95% of my data, I'm going to get a different highlighter color. 95% of my data is going to be within here, within this right here. That's 95% of your data. So it includes that 68% plus 13.5% on either side. So within 2 standard deviations of our mean. And I'm going to remind you, anything out here, well, I need the pen on. Anything out here or out here are outliers. So anything outside of that 95% are outliers. But we still need to consider the far outside here. Uh-oh. 99.7% of our data is within 3 standard deviations of the mean. 99.7% of our data within 3 standard deviations. So it adds 2.35% onto either end of that 95%, which brings us to 99.7. Then anything outside the 3 standard deviations, that's 0.15%. And that includes anything off to infinity in both directions. This diagram is going to become super important. You're either going to need to draw it or a lot, or you might want to print out like multiple copies of this so that when you're doing your homework, you can label it, because it's going to be helpful being able to label it. Same thing with the test. You're probably going to draw it or have printable copies to label. I draw this so many times. When I teach AP stats at the high school, the kids are frequently asking me a question, and then I just walk up to the board and quickly sketch one of these and then write all over it and all of that. I draw these so frequently. So super important. If you have nothing else printed out, this is what you want printed out. Those of you drawing, I'll give you another moment. It's all rainbowy with all of my highlighters on it. We're going to do some examples using the empirical rule. So now, when you, if you visit the tutoring center for help with the empirical rule, they're going to try to use fancy calculator functions. We are not doing fancy calculator functions with the empirical rule yet. So we're not going to until probably next week. So make sure that you let them know that you need to use the empirical rule to answer the questions. Because otherwise you're going to end up with the wrong answers, because these are approximate and the fancy calculator functions give you exact. And the homework is looking for approximate based on the empirical rule. Just letting you know. All right. Going to the next screen unless anyone needs to wait. All right. So here is, I don't know what this is, but I'm sure many of you medical people might know what this is. So this data represent the serum HDL cholesterol of 54 female patients of a family doctor. So this is a sample of 54 women and their serum HDL cholesterol levels. All right. So we're going to compute, don't worry, I'm not making you do this. We're going to compute the population mean and the standard deviation. We're going to draw a histogram to verify it's bell-shaped. So you need to know the empirical rule only works if our data is bell-shaped or normal. It only works when it's bell-shaped. I don't believe I'm going to ask you that question, but you need to know that. So here is, hold on a second here. So here is my histogram, and I have a population mean and a standard deviation. This is really beautiful. I need a pen. Hold on a sec. Okay. I'm writing these down. Now, my questions one of the questions is going to vary slightly from what you have on your PowerPoint. So this isn't a perfect bell-shaped. There's a slight skew. I mean, this is kind of what real world data looks like. I mean, there's a slight right skew, but it's bell enough. I'm going to call it mostly normal or approximately bell-shaped. Okay, I wrote down the mean and the standard deviation. So I'm going to write them down. My mu, it's not a mu though. It is actually an X bar because it's sample, 57.4. And then my standard deviation, what the heck? Standard deviation is about 11.7. So this is the thing that's different from your PowerPoint that you printed off. I'm looking for the percentage of all patients that have serum HDL within 2 standard deviations of the mean. So going back to, we're going to take this right here. So I'm going to take 57.4 plus 2 times 11.7. So I'm going to put that in my calculator. So that's 80.8. So that is the upper. Then I'm going to do 57.4 minus 2 times 11.7. So this is going to be our actual. And then we're going to look at how it lines up with our empirical rule. So there's a method to my madness. So the lower is 34. So I'm going to look at my data set, and see how many of them are between 34 and 80.8. That's what I'm going to do right now. So let me go back to my data set. There it is. So I'm just going to highlight them, mostly because I like my highlighter tool, and I'm going to look for which ones are between those two values. Might be easier to go the opposite direction, but I don't want anything lower than 34 or greater than 80.8. Doesn't look like I have any more, do I?
You're not kidding. It encompasses like all of it.
Yep, there's 2 that are not. So I have 2 of them, these 2 right here. So 2 out of 54, so 52 out of 54 are within 2 standard deviations. So that is approximately 96.3%. So you may recall that 95% of our data is approximately 95% of data is in between 2 standard deviations of the mean. 96.3 is pretty darn close to 95. So I think that we can say that our empirical rule is fairly accurate in this case, because if I took one more away, that would be 98%. Or if I added one more, then I'd be down to 94.4. So pretty much it had to be 2 or 3 in order to fit in the empirical rule. So let's go look at the empirical rule here. I'm going to jump over here. So what I did is I took my diagram, my empirical rule diagram, and I put the mean right in the middle. So this right here is the mean. Then I added 1 standard deviation to the mean, and I got this. Then I subtracted 1 standard deviation from the mean, and I got that. So I'm just labeling my empirical rule table. Then you already saw these values because I just calculated 2 above and 2 below. And then I also calculated 3 above and 3 below. So I just labeled my empirical rule chart with what works with our own data value, with the standard deviation and the mean that I got with the calculating with this data. So go ahead.
So I see where the 80.8 and the 34
So this is
come
the
in.
mean.
That's within the 2, or that's within the 2.35%, right?
Yes.
Okay. But where did this 69 and the 40? So that's within 1 standard deviation. Is
Right.
that either direction? Okay, so
Yeah.
those values. Okay, I see how this is working now.
Does this
Okay,
help?
I understand. Yeah, that makes sense. Yeah.
Okay, good. Oops, this is a minus. There we go.
Okay. I understand now.
Yay,
All right. I
good.
just had to
Good.
look at it for a minute.
No problem. No, the thing is that this class is like learning a foreign language, but once you get it, you get it. And so I just need to make sure that I can communicate it. So questions are really helpful. I appreciate the questions. Okay. So now we're looking for what percentage of all patients have serum HDL between 34 and 69.1. So what I'm going to do is I'm going to highlight the areas that work. So 34 is right down here. So this right here, this right here, and this right here are between 34 and 69.1. So all I'm going to do is just add them. 34 plus 34 plus 13.5. So we're just going to add those. So 68 plus 13.5, we have 81.5%. This is what you're going to be doing in your homework, is the same thing. This is why the diagram is so helpful.
I'm gonna redraw this thing.
What was that?
I'm gonna redraw this thing for this slide.
Yeah. Hopefully you have a printer and you can just print it off afterwards and have a nice, lovely drawing. Okay, we're going to do the next one.
Where did like the mean 25 and all that come from?
Well, okay, I'm confused. Where did the what come from?
Okay, so in the middle we have the mean, which is the 57.4, and then off to the sides, I understand we subtracted one and then we added one. But
Right.
then where did the rest of the numbers come from? Because then there's 25 and 25.
Okay, so then I added the standard deviation again to 69.1 plus 11.7 gives me 80.8. This is a 2 sigma. That's a sigma. These are
Sigma
sigmas.
kind of looks like a 5.
Yeah, these are sigmas. Sorry, they're really ugly. My sigmas are not beautiful.
Oh, so you did 57.4
Those are sigmas.
for
Yeah.
I thought the same thing when I saw it.
Sorry about that. Those are sigmas. Yes, sigmas. Why don't they make it an easier symbol instead of like, it's a weird, almost like a weird upside down Q or something. Okay. So are we okay?
wait, hold on. Okay. So you're just counting out then to
Yeah,
add or
all I'm
subtract
doing is
those.
just
Okay.
57.4 plus 11.7 gives me 69.1. Add another 11.7, I got 80.8. Add another 11.7, I get 92.5.
Okay.
And then from 57.4, I just kept subtracting it.
Okay.
Yeah. Okay.
Thank you.
So now we're going to go look. It wants to know the I'm not even going to go back there because we just did the actual 2 standard deviations away. So I'm not even going to go there with this one. I'm going to tell you the actual percentage of patients that were between 34 and 69.1 was really close. I believe it was 83%. So but in your homework, you're going to be given questions where it asks you, it'll give you a standard deviation and a mean, and it's going to want to know what percent of people are between 2 different values, and you're just basically going to be adding and subtracting standard deviations. So sketching this really quickly or using one that you had printed out and label it is going to be really helpful. Okay. Any questions before I move on? I think we're at 3 yes, we're at 3.4, and this should be 3.4 and 3.5. 3.4 and 3.5. It's been an hour. I think that we're going to take a quick break. I'm going to give you guys 5 minutes to stretch your legs. And because this is a long class, we have 3.4 and 3.5, and then we're going to do the lab. So I'm going to give you a minute, give you 5 minutes, and I'm going to mute and all of that. So I'll see you in 5. Let's see what time it is. It's 6:02. Come back at 6:07.
on the table. You should put it against the stairs.
All right. Welcome back. I know it's only 5 minutes. If y'all want longer breaks, I could do longer breaks. I just don't want to keep you here too late. I'm more than happy to. It's a democracy. I don't want to be be a dictator here and say we have to only take 5 minutes. I just feel 5 minutes gets you up and around and get you a drink of water, all that. But if y'all decide we want longer breaks, we can do that. Okay. So we are at section 3.4 and 3.5. In your book, obviously they're two separate things, but the assignment is one assignment. So I'm keeping them together. Okay. So first we're going to talk about z-scores. So all z-score is how many standard deviations a data value is from the mean. Tells you the distance that data value is from the mean. So for example, a z-score of 2 tells you that whatever data value you have is 2 standard deviations away from the mean. So any z-score that is larger than 2 or smaller than -2 would be an outlier, because remember, outliers are anything more than 2 standard deviations from the mean. Z-scores can be positive or negative. A negative z-score means that your data value is below the mean, or so less than the mean. A positive z-score tells you that your data value is greater than the mean. Z-scores don't have units, so we wouldn't say minutes or hours or anything like that. It's just the z-score is this. So to find the z-score, you take your data value, you subtract the mean from your data value, and then you divide by the standard deviation. So both of these are the same thing. They're just with the different symbols. So if it's population, it's x minus mu divided by sigma. If it's sample, it's x minus x bar divided by s. Give you a second to write these down and we will move on. We will do some math. One reason we use z-scores is it standardizes things. So for example, let's say I had 2 different classes. One of them had 30 people in it, and the other one had like 35, 40 people in it. I don't know. And I was calculating the mean and the standard deviation. And maybe this class, I had one class that was AP and one that was regular. And the average test score in one class was 78%, and the average test score in the other class is 85%. Saying that somebody had an 88% test score in the class that scores better, it doesn't mean as much unless I'm saying, oh, the z-score on that one is 1.8, whereas somebody got an 83 in the other class and that z-score is 2.3. A 2.3 z-score would be an outlier, which means that person did really well with respect to the rest of the class. So looking at z-scores, it kind of puts it all like, it's kind of like unit conversion, comparing gallons to gallons rather than gallons to cups. So we're standardizing things. So we're comparing apples to apples. All right, we're going to do some examples to kind of help you with that. Here's the first one. The mean height of males 20 years or older is 69.1 inches with a standard deviation of 2.8 inches. Okay. The mean height of females 20 years or older is 60, whoa, I hate it when it changes it to an eraser, 63.7 inches with a standard deviation of 2.7 inches. So I have Kevin Garnett, whose height is 83 inches, and Candace Parker, whose height is 76 inches. We want to know who is relatively taller. They're both very tall, but we want to know who's relatively taller. So compared to other males or compared to other females, who is relatively taller? So we're going to calculate the z-scores. So I'm going to do Kevin Garnett first. So remember, it is x minus mu divided by sigma. So I'm going to do 69.1 divided by, whoops, that's not right. He is 83. What the heck is going on here? 83 minus 69.1 divided by the standard deviation of 2.8. Now, if you put this whole thing into your calculator, put parentheses around your numerator. Otherwise, you're going to end up with bad numbers. So his z-score is 4.96. This is his z-score. Make that a z. So let's go ahead and do Candace Parker. I'm going to take the, once again, x, which is 76, minus the mean, which is 63.7 inches, parentheses if you're putting the whole thing in your calculator, divided by the standard deviation of 2.7. So I'm calculating a z-score. Her z-score is 4.56. So to put this in perspective, remember that an outlier is any value more than 2 standard deviations away from the mean. Therefore, an outlier is anything more than a 2, a z-score of 2. These two very, very tall people are almost 5 standard deviations above the mean. That's crazy. So crazy. They're definitely in the 0.15%. However, Kevin Garnett is relatively taller because his z-score is larger than Candace Parker's z-score. Questions here? The next ones are yours, so it's a good time to ask questions. All right. So now we have baseball. So the Los Angeles Angels and the Colorado Rockies, we're going to find out who had a relatively better run producing season. So the Angels are in the American League and they scored 773 runs. The mean is 677.4 and the standard deviation is 51.7. The Rockies, they scored 755 runs. They're in the National League. The average is 640 and the standard deviation is 55.9. I would like you to calculate both of these z-scores. I'm going to work quietly behind you. Usually what I do is I let everybody get a head start and then I work quietly behind you. So if you get stuck, you can look up at the screen. So go ahead and get started calculating those z-scores. All right. So for the Angels, I got 1.85, and for the Rockies, I got 2.06. So relatively, the Rockies did better. In fact, they had an outlier of a season. Their season was really good because their Z-score is 2.06. Since it's greater than 2, their season was an outlier. So yes, they scored fewer runs overall, but compared to the the average in the National League, the average and the standard deviation, they did really well. They had a better season. Questions? That's Z scores for you. All right, I believe well, nope, we're not in 3.5 yet. Okay, so we're going to jump. So what I would like you to do is I would like you to take mean and standard deviation, and I would like you to either put them on a shelf or put them in your pocket, put a pin in them. We are not going to be dealing with mean or standard deviation for a little while. So just set those aside. Just put them in your pocket. So we're going to step away from mean and standard deviation, and we're going to start talking about median. And we're going to talk about median's version of standard deviation, which is called IQR. So set that aside, and we're going to come back to it. But for right now, put it away. So we're going to talk about quartiles. So you may recall the median divides the top half of the data from the bottom half of the data. It cuts it straight in half. In order to find the median, we just find the smack dab in the middle. First, you arrange them from smallest to largest, and you cut them smack dab in the middle. So quartiles divides the data into 4 equal parts. So our data is being divided into 4 equal parts to get quartiles. So the first quartile, as you see right here, divides the bottom 25% of your data from the top 75%. So it is basically the median of the bottom half of your data. Don't worry, we're going to math all this out. The second quartile is the same thing as your median. We almost never call it a second quartile. It's just a weird thing to call it. We almost never call it that. Pretty much never call it that. So it is the middle of your data, and it divides your data top 50% from the bottom 50%. Third quartile is like the median of the top half of your data. It divides the bottom 75% from the top 25%. And, if you're putting it in your notes, if you don't have it printed out, even just drawing this diagram is probably enough. This diagram right here is super useful. So I'll give you a second to draw that. Okay. So in order to find the quartiles, okay, these are a lot of words. I don't recommend writing all of these words. This is a whole lot of words. So arrange the data in ascending order, so smallest to largest, then find your median. So we've already done that. We've found medians before. We know what the median is. Then what you're going to do is you're going to take the bottom half of your data, so all of the data below your median, and you're going to find the median of that bottom half of the data set. And that will be quartile 1. Then you take the top half of your data set and you do the same thing. You find the median of the top half of your data set. That is quartile 3. That's it. That's all we do. So you're just finding the median 3 times, basically. We're going to do math, or I'm going to show you, and you're going to see this is probably the easiest thing we do all day. Okay. So let's do this.
I have a question.
Yes.
So the M is quartile 2 then.
Yes, the M is quartile 2.
Okay, so that's the mean. Okay, gotcha. Okay.
That's the median.
Okay.
Yes. No, you're good. Okay. I already took this data and I arranged it from smallest to largest because I just time saver. So this is there was a 25-mile-per-hour speed posted through a construction zone. They took 14 randomly selected vehicles and the data is below and what their speed was. Notice that only 2 of them went below 25. I think that's just terrible, but it's probably pretty accurate. So we're going to find all of the quartiles, and it says interpret. Interpret, in my opinion, is usually let's write a lot of words, but that's not exactly what we're doing. So we're gonna find the median first and then find the quartiles. So let's just start there. There are 14 data values. Therefore, the median will be right between 7 and 8. So my median is going to be right in between here. So it'll be at 32.5. I could have done 32 plus 33 divided by 2, but these were like easy ones. This was the easy math. So this is my median. I usually write MED instead of just M. So my median is 32.5.
So these are just whole numbers. Our median can actually fall anywhere within that whole number.
Yeah, it's going to be just halfway between. It's exactly halfway between the two values.
But could it be like 32.2, for instance?
Well, it could if it's halfway between the two numbers. It's going
Okay.
to be exactly halfway.
Gotcha.
Yeah. Okay. So now to find quartile 1, I go down below my median and I get the halfway point there. There's 7 data values below the median. Therefore, the fourth one, this right here is Q1. Same thing up top. I take those top 7 data values and the fourth one, that will be Q3. And that's really all you're doing when you're finding your quartiles. It's really that simple. And so all the interpret part is that this is 25% of my data. This is 25% of my data. This is 25%, and this is 25%. It broke it into quarters. Uh-oh. Broke it into quarters. Stop it. Okay. So that's all quartiles do, is break it into quarters. Questions? Okay, give me a second.
So as far as dividing it into quarters, we have an even number here. How about if we have an odd number of total data points?
So if I had, let me just put random numbers here. 24, 38, 65, 74, 93, 108, 1, 2, 3, 4, 5, 6, and 121. Okay. So 1, 2, 3. So this right here would be my median. This right here would be quartile 1, and this right here would be quartile 3.
Oh, okay.
Yeah. You're like, why don't we do this all the time? This is so much easier than mean and standard deviation. But when it's normally distributed, you still want to use mean and standard deviation. Besides, there's so much more we can do with mean and standard deviation than we can do here. It's always into quarters. Yes. We're not going to use, yes, Andrea. We're not going to use, well, I don't even, what would it be? Tritiles? We're not going to do like triples or fifths or 28ths or anything like that. It's always going to be breaking it into 4 pieces. Good question. Nobody's ever asked me that. That's a really good question.
I'm a little confused. So 32.5 is just for the median. It's not actually included in the top 7.
It is, no, it is not part of it. It's not a data value. It's just the middle of our data set.
Okay. Okay, that makes sense. All right. Cool.
Yep. All right. I'm going to move on to the next one. Okay, so this is the interpretation. So this is basically, I wrote it here with the 25%. but I am firmly believe that textbook writers get paid by the word because everything is super wordy. I'm sure if you've read these sections in the textbook, they way too many words. So 25% of our speeds are less than or equal to the first quartile. 50% of our speeds are less than or equal to the second quartile. 75% are less than or equal to the third quartile. Notice this right here, though. This is important. Less than or equal. Less than or equal. So this right here is included in the bottom part because it is a data value. This right here is included in this technically because it is in it is a data value. But it's not, it shouldn't, it's not going to affect anything, but just it's less than or equal to. So if you had to decide which direction to pull it, that's the way you would pull it. But you're never going to get a question that asks you like which quartile is 38 in. It would be more likely to ask you which quartile 34 was in. It's going to be really specific and really clear. So don't worry about the ambiguity there. Okay. All right. Once again, I put this in ascending order for you because I have a really hard time putting things in ascending order, so I tried to be nice. So the Highway Loss Data Institute collects data on collision coverage claims. So for insurance, in fact, that's where stats is used most is insurance claims. If you really, really love stats, if you became an actuary, actuaries start off really close to six figures. That's like a starting salary. I considered it very briefly before deciding I didn't want to work in a cubicle my whole life and actually wanted to talk to people. So actuaries start off really close to six figures. They make a lot of money and they do stats for a living. So they calculate like they would calculate things like the risk for life insurance policies, for car insurance claims, things like that. So they're calculating risk. That's all they do. So they take this data here and they're looking, this is just raw data we haven't done anything with. It's randomly 18 claims against insurance for collision. Look at this one up here. This one's crazy, $21,000. All right. So we're going to find our quartiles for this data. So there's 18 there. So once again, our median is going to be between 9 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It is going to be in between here. So I will do 1657 plus 1953, then divide it in half to get my median. But wait, actually, hold on a second here. I don't want to make you put all of these in your calculator, but I'm going to go back. So this would be 1805. 05. And that's dollars. Okay. I'm going to stop here, put a pin in this one because I forgot to show you the calculator functions. So hold on, let's go back here. Because this is only 14 data values, we're going to go back to our calculator. Boom, boom, boom. Let's put these into the calculator. Clear. So I'm going to go to stat again and edit. So hit stat, edit. Remember to go up and clear out your list. So remember that's clear. Arrow up and hit clear, enter. Whoa. Clear, enter. Don't hit delete, hit clear, enter. And I'm going to put in the highway, the construction zone data. The speed data, if you will.
I have a quick question, Melissa.
Yes.
My calculator started writing it below instead of at the top on the graph. How would I fix that?
So what do you mean start writing it below?
Where it says L1 parentheses 1.
Uh-huh. So it should
It's
go down. It'll put it underneath of it after you clear it out.
it's just going like in a line instead of putting it back on the L1.
So it's going like
Does
over
that
here
make sense?
instead when you hit enter.
No, just at the bottom where it says L1.
Okay. Oh, so you're not hitting enter between them. If I highlight L1, it's going to show them.
Oh, gotcha. Okay.
Yeah,
Thank you.
you're welcome. It took me a second. It's like, wait. Okay. All right. So I can put all the data in here. I'm going to give you all a second to catch up. And we're just going to do one variable statistics again because I want to show you the rest of that screen. Give you all a moment to put that in there. Okay, does anyone need another moment? Okay. Once again, we hit stat, go over to calc. We want the first option, which is one variable statistics, one var stats. You should still have L1 in here. It should still be there. Go down to calculate and hit enter. Okay. I don't care about the mean. I don't care about the standard deviation. We don't care about all that. We are going to scroll down. Unless I have a minimum of 20, my lowest data value is 20. Look at it gives us our quartiles. I have Q1 of 28, which is what we found. Median is 32.5, which is what we found. Q3 is 38. My max is 40. So you don't have to put them in ascending order. You can just put them in your calculator. It will do all of that for you. Your calculator is your friend for sure. So all of that is right there in your calculator. So it gives them right in a row. I love these calculators. Every time I teach this class, I learn something new.
Are we allowed to use these on the test?
Yeah, absolutely.
Awesome.
You have to tell me how you got it, though. You have to write down one var stats and then tell me what came out. So you have to tell me I used this calculator function because, so if you show me I used this calculator function and this is what came out, if you have the wrong answer, I'm going to be like, okay, so they probably had a typo. You're going to lose fewer points than if you just give me a wrong answer and don't show me what you did or tell me what you did. If that makes sense.
Makes sense.
Because typos in the calculator are super common. All right. So I'm going to go back here. We are not going to put these in the calculator because this is pretty quick and easy to do. I just wanted to show you the calculator is a thing. And because these are all in ascending order already, it's pretty easy. Okay. So now I have 9 below. This is my median. I have 9 below my median and I have 9 above. Therefore, 1, 2, 3, 4, 5. This right here is my Q1. 1, 2, 3, 4, 5. This right here is my Q3.
So it's from those numbers on and back, right?
What was that?
I thought Q3 was the top half.
Well, it is. Those are the higher numbers.
Okay, I got you. I see what's going
Q3,
on.
yeah. Q3 is the higher numbers. So I'm not going to interpret them. I mean, basically, this is 25%. And this stuff right here is 25%. You don't have to write that in there if you don't want. I think my point is gotten across. Each of those is 25%. So I'm going to write these down here. It's up to you if you want to write them down. Okay. We're going to now talk about I think I have one more mean or median to do. One that has even numbers, I think. Hold on a second. We'll see. You'll see.
I'm so sorry. I have one more question.
Yes.
So going from the bottom or the top half, bottom half, the lower numbers,
Yes.
why did we count off 5 from the left instead of the full 9?
Well, there's 9 on the top, and so it'd be the 5th number. is the one that would be our Q1. I could count backwards. 1, 2, 3, 4, 5. But because there's 9 below the median, it's the 5th number is our Q1. The number smack dab in the middle.
Oh, I see. Okay.
And my median is right here.
I feel so
No, you're fine.
dizzy right now.
You
Oh
know,
my
we
gosh.
all
Okay.
have lives that like take us the whole day, and then we have to try to make our brains function in the evening. I
Yeah.
get it.
Yeah.
I
I get
have
it.
on Tuesdays, I have 5 grandkids all day that are crazy. So my brain is shot by the time I get here sometimes. All right.
Gotcha.
Yeah. It's going to be worse once I have high schoolers. Okay. So interquartile range. Okay. Inter Interquartile range is the middle 50% of our data observations. So the middle 50%. So it's Q3 minus Q1. So it is the range of that middle 50% of our data. So I'm going to go back real quick here. So the interquartile range, I'm going to use my lovely highlighter because I can, would be between here. This middle 50% would be the interquartile range. This is the median's answer to standard deviation is that middle 50%. Okay. So I would just take Q3 minus Q1, and that would give me that interquartile range or IQR. Most of the time, we just call it IQR because interquartile range is kind of a mouthful. So it's that middle. Yes?
Sorry, does that include wherever you highlighted? Did that include the 28 and the 38?
Well, I take 38 minus 28. So you just take Q3 minus Q1 to get that. So kind of includes them as far as they're the endpoints of it. So you just take, well, I'm going to do that on the next page. You just take Q3 and subtract Q1. So it's just the difference between those. Yeah, technically, I guess it does include them.
Thank you.
So I'll get to that next screen. Here it is right here. So my Q3 of the speed data is 38 and my Q1 is 28. So I take the 38 minus 28, I get 10. So the interquartile range is 10 miles per hour. The purpose of the interquartile range, what we use it for the most part, is to look for outliers. Now, we have the way to find outliers with standard deviation and mean. We've already talked about that. And then we can find outliers using median. Sometimes something will be an outlier for one and not the other, and it's okay. So don't freak out if you find it as an outlier when using median, but you don't find it as an outlier using mean, or vice versa. It really depends on which one you've focused in on and which one you're using for your whatever your situation is, which one's appropriate. All right. So I want to show you why we use median. We've talked about it a little bit last week. A median is better when there's outliers or your data is skewed. So we have a 15th car. It travels through the construction zone at 100 miles per hour. Let's take a look at how it changes your mean and your median. So my mean with that 100, without the 15th car, without that 100-mile-an-hour car, was 32.1. With that 100-mile-an-hour car, it went up by 4.6. It is significantly higher. But the median, it only changed by a half mile per hour. Standard deviation without the 15th car, standard deviation is 6.2. With that 15th car, look at how different standard deviation is. It is extremely different. It went up by a lot. Interquartile range, my IQR, it was 10 miles per hour without the 15th car. It only went to 11 with the 15th car. So it doesn't change. So the median and the IQR, they're considered resistant to outliers, which means that they don't change much when there's outliers. When you have extreme values, they don't change much. Therefore, if we have a nice symmetric distribution, we are going to use mean and standard deviation. If we are skewed, we are going to use median and interquartile range. I'm going to give you a second if you're writing any of this down. I believe this is the end of 3.4, and then we'll jump into 3.5. I'm going to get a drink of water while you're writing stuff down. Right. If you need another moment, make sure you stop me.
I need another moment. Sorry.
Alrighty. Oh, no, you're good.
Thank you.
You're welcome.
So I have a,
Yes.
sorry, I can use some
No, you're
questions.
fine.
So we don't actually calculate the standard deviation based off the numbers that we have. Standard deviation is, or we do calculate the standard deviation, right?
Yes.
Okay.
And I would just use your calculator. Do not hand calculate it. Just use your calculator.
Okay. Okay. All right. That makes things easier.
Yep. Rely on your calculator. Definitely.
Sorry, I might be asking stupid questions. I'm sorry.
No such thing as a stupid question. All right. So here's how we find outliers using mean and median and interquartile range. So you find your quartiles, figure out what your IQR is, and then here is how we find the outliers. Don't worry, I'm going to math it. You take the first quartile minus 1.5 times your IQR. Anything lower than that value is an outlier. Then you take your third quartile and you add 1.5 times the IQR, and anything higher than that value will be an outlier. We're going to math it and you will see. These are fences. We generally don't call them fences when we're talking about 2 standard deviations away from the mean, but if you call them fences, nobody's going to get mad at you. We usually just call them upper boundaries or upper limits, upper and lower limits or upper and lower boundaries. If you call them fences, nobody's going to be mad at you. Fences is a good word, but it's definitely fences with median and IQR. So we're going to calculate it. We're going to calculate it with our speed data. Okay. So our speed data, our first quartile is 28, our third quartile is 38, and our IQR is 10. So I'm going to take 28. So I'm going to take the 28 and subtract 1.5 times 10. So this right here is my IQR. And this right here is my Q1. So 28 minus 1.5 times the IQR is 13 miles per hour. Then this is my Q3. This is my IQR. So 38 plus 1.5 times the IQR is 53 miles per hour. We don't have any values less than 13, and we don't have any values greater than 53. Therefore, we don't have any outliers. So you just look for values lower than your lower fence or higher than your upper fence and see if those exist, then you have an outlier. Right. Let's do it with, let's do that math with the collision data. Okay. So my Q3, I don't know why I'm doing Q3 first, just because. And then the Q1 was 735. So now I need to find that IQR. Okay. Let's math that out. So this right here is my IQR. Come on. Ugh. So that's my IQR. So to find my lower fence, I'm going to take Q1, put take Q1 minus 1.5 times 3933. I'll let you know this is going to be a negative number. That's okay. Negative 5164.5. That's really ugly. My upper fence will be 4668 plus 1.5 times 3933. Zero or 10, 567.5. I'll let you write this down and then we're going to go back and check our data and tell you we do have an outlier, but we're going to go check our data anyway. So any value lower than negative 5,164.5 or higher than 10,567.5 is going to be an outlier. Those are our fences. Obviously, we're not going to have anything lower because then their car is in better shape after they got in an accident. Which there's some hoopties out there I've seen that they might be in better shape if they were in an accident. So I'm going to pop back over to the data. If I can get there quickly, come on. Come on, let's hop back to my data. Oh, there we go. So this value right here, this 21,147, that one right there, that one is higher than the 10,567.5. So that right there is an outlier. I'm going to write it on that other page. Because that value is outside my fences, outlier. So this one is an outlier. Must have been a pretty nice car if they didn't just total it. Questions on finding outliers with median?
So I'm a little confused on how we got to the 21,147.
So this value, if I go back, I'm looking at, do I have any values higher than 10,567.5? Because that was my upper fence. So notice this right here is higher than my upper fence.
Okay. And then nothing was obviously lower than negative
Right.
5164. Okay.
Exactly.
All right. All right. I'm seeing it now.
Yes. Okay, good. All right. So we're definitely in 3.5 now. Don't worry. We're almost done, y'all. We're almost done and then we'll get the lab won't take very long. Okay. So the 5-number summary. So we have, if I have a super large data set, let's say that I have a data set that has 87 pieces of data. I don't want to have to always look and dig through 81 data values. Nobody wants to do that. It's not fun. Therefore, we can organize our data in what's called a 5-number summary, which just gives us the 5 most important numbers. And the 5-number summary will always be in this order, so you don't even necessarily have to label them. We have the minimum, then we have quartile 1, the median, quartile 3, and then the maximum. It kind of goes in the order of a number line. Don't have to write the number line, but I'm going to write it just because it's a nice visual. It kind of goes in the order of a number line because you're going to have the minimum is going to be on the far left. Then you're going to have your first quartile, then the median, then the third quartile, and then the maximum. They kind of go left to right, lowest to highest. So you don't even have to label them. You can just say that it's a 5-number summary and give me those 5 numbers. It is super helpful because then you can just disregard the entire rest of the data set and just look at those and answer questions based on that 5-number summary. Very useful. So we're going to actually do some 5-number summaries. Okay. So the 5-number summary of the speed data, and then we're going to do the 5-number summary of the collision data. Oops. So the speed data, I wish I would have written this stuff down. Oh, wait, it's on my calculator. On my calculator, if you scroll down here, I went the wrong way. They give you the 5-number summary in that exact order. I'm going to write it on my iPad while I'm looking at it here. So it's just 20 was my lowest. Q1 was 28. The median was 32.5. Q3 is 38. And then my maximum is 40. So I'm just going to go back to my. So you just write it like that. You don't even have to label them. Now, if you're uncomfortable not labeling them, if you don't like it that they're just sitting there, nobody's going to be mad at you for doing this. No one's going to get mad, but it's not necessary. And let me tell you, your homework will not label them. It will just tell you, we gave you a 5-number summary. Answer this question. So if they give you a 5-number summary, this is all you have. So now the 5-number summary of the collision data, thankfully, I already have that written down. Well, kind of. What is my lowest value? I do have that. Okay.
20. Yeah.
Yes. Question?
No, I was just 20 is our lowest value, right?
Right. Yes. So of my collision data, I already have this written down over here because I'm going to be doing a box plot with it in a minute. My lowest value is 180. Oh, I guess I need a pen on. 180. My Q1 was 735. The median was 1805. Q3 is 4668. And my highest value is 21,147. That's my 5-number summary. Once again, you do not have to label it. You just put it there and say, oh, that's lovely. And that's it. Questions about 5-number summaries? It's kind of nice to not have to look at a ton of data set values and just be able to do all the math you need to do with just these. So my IQR, just FYI, if I was going to do an IQR, I would just take this 38 minus the 28 right there that I see on that first one. It gives you Q3 and Q1, so you can do that. You can use that to calculate your outliers. You'll be able to see whether or not there's an outlier there because, like, for example, here, once I calculated 1.5 times my IQR and added it to that, I would see that this number is higher than that. So I would know, hey, there's an outlier there. So everything you need is right here. Okay, let's talk about box plots. Okay. So for a box plot is a way that we graph things when we have the median rather than the mean. There aren't a whole lot of ways to graph things with just a median. Now, in the end, I'm gonna be comparing box plots with histograms so you can kind of see the skew and all of that. And it's kind of interesting. But in general, when we're using the median, we just make a box plot. So a couple of things that are important. First thing you want to do is after you find your 5-number summary, you find all of those pieces. Then you need to calculate your lower and your upper fence. So make sure you calculate the upper and the lower fence because we're going to be putting that on the box plot. You're going to draw a number line on the bottom underneath where you're going to graph your box plot. You draw a number line. This is a standard number line. You can count by ones, you can count by tens, you can count by hundreds of thousands, 500s, whatever you need to count by. You're not just putting the data values on there. In fact, most of the time, the data values aren't even represented on your number line. They just fit in the range of it. So it's just a standard number line. We're going to be putting vertical lines at Q1 median and Q3, and we're going to make a box out of it and label our fences. I wouldn't write these steps down. I would just pay attention to the way I do it when I do it. Then you're going to draw a line. This is important though. from Q1 to the smallest data value that is larger than the lowest fence. So our whiskers, our lines only go to the last data value inside the fence. Then you're going to draw a line from Q3 to the largest data value that's smaller than the upper fence. So the line above will only go to the last data value that is still inside the fence. If you have an outlier, indicate it with an asterisk. I'm going to show you some examples. We're going to draw one together, and we're going to see one that's already drawn. So an asterisk represents an outlier. So once we actually make one, it'll probably make more sense. So I'm going to make a box plot on these credit card interest rates. So here's a whole bunch of data, and I'm going to use this data to create a box plot. You don't have to write the data down or even care about it. All right. So my Q1 is at my Q1 is at 12. My Q3 is at 14.4. So I'm going to put highlighter here. I put vertical lines at Q1 and Q3. Those are way too fat. I'm going to get a skinnier highlighter. There we go. So Q1 and Q3, I put vertical lines there. Then I found my fences, or then I found my medians. Where's my median? My median looks like it's a little bit above 13.5. So this right here is the median. I'm going to write this down. So this is the median. Please do not label them on your box plot. I'm just labeling it for you so you can see where they are. These are my fences right here. This is a fence. That's my lower fence. This is my upper fence. Those are any value outside of those values are outliers. So you draw the whisker to the last data value that is inside the fence, which looks like it's about 9.8. So the lowest data value inside my fence is about 9.8. Same thing with up above. This right here looks like about 14.5 is the last data value inside my upper fence. So the whisker only goes to that last data value. Then I have an outlier over here. This looks like it's about 6.5%. I have an outlier there. Indicate that with an asterisk. Before we move on and do our own, I want you to take a look at this number line. Now I do want this to be fat. This number line down here, I didn't do it. Okay. This number line is a standard number line. I mean, my data is not standard. It has all sorts of decimals and everything. This is just a standard number line. The number line needs to include, I need to be able to graph all the values like above it, but it's just standard. I just counted by ones. So it's before we make our own, any questions?
We don't need to, are you implying that we have to change the number line then, or it can be in the format it's in?
I want it in this format. I wanted just a standard number line underneath of it.
Okay,
That's what I'm looking for. Yes. Good question. Anyone else? Okay, we're going to create our own. You're going to follow along with me. Please do this while I do it. I'm going to walk you through doing one. On your first test, see, I don't like surprises, so I'm telling you, on your first test, you will be required to create a box plot. So follow along. If you need to put a Post-it note to bookmark this page in your notes, whatever you need to do, rewatch this part of the video, whatever you need to do, there you will be drawing a box plot on your first test. Okay, so I'm going to use the 5-number summary from the collision data to create my box and whisker plot. Okay, so I've made this a couple of times, just letting you know. I have created this so I know what I'm counting by. I have numbered it wrong so many times, and now I finally know how to number it correctly, just letting you know. So I know what I'm counting by. So I'm going to start with a number line. going to draw a standard number line. It's going to be pretty long. Oops, I want that. Come on. Come on, let me move this. I want it to be pretty. Come on, there we go. So standard number line. It's nice and pretty. It's beautiful. It's straight because the software I'm using makes it nice and straight. All right. Even though it's going downhill, but that's okay. I count by 500s, but I only write the thousands because I know. So my zeros here. You don't always have to have 0 on your number line, but I do because I have a fence that is in the negatives. So so 500,000, 2,000, 3,000. Okay, so I'm going to show you a trick. My last data value, I have a data value at 10,034. Then my next one is 21,147. There's a little trick of the trade here. There's something called putting a break in the graph. So this, let's undo that. So this right here, that's breaking the graph. So basically what it's telling, if you put something like that on your graph, you're telling the reader that you cut a big piece of your graph out. So if you need to cut a big piece of your graph out, put a break in your graph, because now I'm going to start, whoops, I forgot a 0 on my 11,000. Now I'm going to start at 21,000. Here we go. I cut out a big part of my graph. Therefore, I can start counting at 21,000. All right. So now I have my pretty number line. I'll give you a second to catch up.
Is it possible can we have multiple cuts in a standard line?
I mean, technically, yes, but we try to avoid it because we like things to be pretty. So if you
Okay.
can avoid it, please do. But if it becomes absolutely necessary, then yeah, why not?
Okay, thank you.
You're welcome. Okay, so now I'm going to put vertical lines at Q1, the median, and Q3. Q1 is at 735, which we're not looking for exacts. You're just kind of approximating where that would be. And I'm probably off, but that's okay. So 735. And then my median is at 1805. So that's right about here. And then my Q3 is at 4668. So it's right about here. Boy, they're not really lined up well at all. I'm going to enclose the box. And enclose the box. There we go.
And what was the upper limit? 45, right? 46, right? So it's
40,
gonna be,
it's 4668.
yeah, that's right. Okay.
Yeah, so
That
we're
could
at
be.
735, 1805, 4668. It's all really approximate. These are not, you're not going to be able to get exact data values off of this. It's mostly looking at shape of things more than anything else. So now I'm going to put my outliers. I'm going to put my fences on. I'm going to use red because it's easy to see. Now, my lower fence is way in the negative. I am not going to make my number line go all the way down to negative 5,164.5. So I'm just going to put it way off here. Uh-oh, that's not what I wanted. I'm just going to put it out here. It's just going to go out here. And you don't necessarily have to label it, but I usually label it just because I kind of want to show the reader that this is super ridiculous. You don't have to label it. It's not something required. If you had one and it was just sticking out there in the negative and not labeled, I'm okay with it. My upper, though, is important. My upper fence is at 10,567.5. So my upper fence is up here somewhere. What the heck is going on here? My upper fence is up here somewhere. That's where my upper fence is. The upper fence is going to become important. Once again, I would not label it. I would just leave it there. Okay. My whiskers. The whiskers go to the last data value inside the fence. So my left whisker, the lower whisker, is going to go down to my lowest data value. My lowest data value is 180. So it's going to go, let's say right about there. That's probably off, but who cares? My highest data value inside the fence is 10,034. So my highest data value inside the fence, it's not going to touch the fence. It's just over 10,000. Probably too far, but that's okay. Oh, that was ugly. I'm going to redo it because I don't like it. Okay. That's my the last data value inside my fence is 10,034. So it goes there. It does not go all the way to the fence. Please don't make that mistake. The last thing I'm going to do is I'm going to make an asterisk for my outlier. My outlier is 21,147. So it is right here. Uh-oh. Somewhere right around there. Close enough. Probably a little low, but that's close enough. And there you go. That's it. And we only have one more slide. Y'all are such troopers, putting up with me for 2 hours. Yes, we still have the lab, but the lab won't take very long. All right. Questions on making a box plot?
I was just curious, Melissa, on the test, we just have to do it as accurate as possible, correct?
Yes, you're going to be showing your work. So you show your work on a separate sheet of paper. Oh man, I forgot to do today, tomorrow morning, I'm going to put up the practice test. So you're going to be showing your work. So on a sheet of paper, you're going to draw your box plot. Things I'm going to be looking for. Are your whiskers just going to the last data value inside the fence? Do you have a standard number line underneath of it? Do you have your fences there? And did you indicate the outlier if there is one? Those are I mean, I will be looking at the thing as a whole, but those are like the main points I'm looking for. Those are the main things that people do wrong.
Okay, thank you.
You're welcome. And yeah, and then the way they do it, so the at the end, the proctoring software asks you to take a picture of your work, and you'll hold it up to your camera and take a picture, and it'll let you review the pictures. If they don't show up well, you can scan them or take pictures of the work and email it to me later. So that works fine, just in case. Any other questions? I mean, obviously my values, it's not exact, but you look at this, you can get a pretty good idea. You can be like, oh yeah, I mean, it's approximately 10,000 is the last data value inside. Yeah, it's a little more than 21,000 is my outlier. That's all I'm looking for is approximate. I want somebody to be able to look at this and say, this is definitely right skewed, and there's an outlier there. I mean, that's pretty much what I'm looking for. I want them to be able to look at this and kind of at least get some ideas about things. Okay, I'm gonna go to the last page. So notice the comparisons here with the box plots and the histograms. So the one on the left is skewed right, and you can see how the whisker is longer on the right than it is on the left. And then look at the second one is symmetric. You can see that the whiskers are approximately the same. My median is basically smack dab in the middle of my box. And then the skewed left over here, My median is not like super centered. My left whisker is longer. You can kind of get an idea of the shape of the distribution looking at the box plot. One thing that's super annoying though is that Excel does box plots vertically and I don't like them. I don't think that there's any way to make them horizontal. It makes the whole thing up and down. All right. Any questions about what we just learned or anything before we get to the lab?
I'm just gonna have to rewatch some of this stuff because it's definitely something I'm gonna need to work on.
Well, that's one of the reasons that this is one of the reasons that I allow that I put the videos up
Right.
is because I want to make sure that you can rewatch them. Plus, people who don't come to the Zoom class, they should be able to watch them. But these videos are better than the ones that are in the week's materials. Those I made in 2020, and I'm a better teacher now than I was in 2020. So definitely, yeah. And I've been trying to re-record them, but it's really time consuming because there's editing involved and things like that. And it's really time consuming. And I just haven't gotten to them all yet. So these are definitely better. All right.
I have
So,
a question.
yes.
I'm sorry.
No.
I'm very concerned about my handwriting. I have horrific handwriting for
Okay.
the notes.
So
I show them.
I am really good at reading messy handwriting. So do the best you can. The most important thing, make sure that you number the problems, that I know I'm looking at problem 11. That needs to be clear, which problem I'm looking at. Usually, if I know what problem I'm looking at, I can decipher it. I mean, I teach high school, for goodness sakes. Think about the high school boys and what their handwriting probably looks like. Many of them are future doctors. So there you go. So I'm pretty good at deciphering handwriting, but if I'm looking at your work and I don't know what you wrote, I will most likely say, hey, what is this? I will screenshot it and I will send it to you and ask you to tell me what you wrote. Hopefully you can tell me, but
Thank you.
I'm pretty good at deciphering handwriting. I've been doing this a while. So, all right. So we're going to do the lab. So I mentioned it last week and I mentioned it in the email. You just need to use the continuous data from the first lab. So that's what we're using is the continuous data from the first lab, which is real easy. You should just be able to have it. You should just copy it and paste it into here. If you don't know how to do that, then you could just retype it because you should only have 21 data value or 20 data values ish, even though I have a whole lot because I'm extra. So the very first thing that we need to do when we are doing lab 2 is to get something called the descriptive statistics tool. I think that's what it's called, data analysis tool, something like that. That's the very first thing that we need to do. I need to hide that.
So,
Okay.
Melissa, a quick question.
Yes.
So I obviously need to do lab 1 before I can do this lab, right?
Right. Yes.
Okay, so maybe I should talk to you after class here.
Well, you can read that there's an instructional video for lab 1 and it'll also tell you how to do it and everything you need.
Okay.
It's
Okay.
right. I mean, you can still ask me questions at the end, but it is in the week 1 materials.
Okay. Cool.
Okay. All right.
There's also a template there as well that you could follow.
What was that?
I was just letting him know that there's also the template that you added for that lab
Yes.
one.
Yes. The template is helpful. Okay. And this template, you guys will also get this template. Okay. So I need the data analysis tool. So if you're in your Excel and you click on data right here or data, however you want to say it, you click on that. Over here on the right, if there's nothing here that says data analysis, then you don't have the tool. Whichever Excel you have over here on the right, it'll say data analysis. If it doesn't say it, you don't have the tool. I'm going to show you 2 different ways to get it depending on your Excel. Hopefully one of the 2 ways will be a way that yours works. So I'm on my Mac right now. I'm on a MacBook, and this is very different than my PC. So with this MacBook, and some people on PC see it this way, I'm going to click on this right here that says analysis tools, and this opens up right here. I want the analysis tool pack. So you just click it on right there and then click OK, and then data analysis will pop up. Then I have the tool. I'm going to pop over to the other. I'm going to quit sharing. Stop sharing. And then I'm going to go to my other computer. And I'm going to share my screen here. Share. Okay. Now I'm on a different, okay, I'm on a different computer now with a different Excel. Most people have Excel like this one. Most people's, it looks like this. Here, my screen is not. Okay. So you're going to go to the top left to File. Right here. Go to File and then go all the way down to Options. And this thing will pop up here. I'm going to show you, wait, hold on again. I'm going to go to Data. This over here is blank. There's no data analysis data analysis there. Okay, once again, File, Options. I want to go to add-ins. So towards the bottom of the screen that popped up, click on add-ins. And then go down to Manage Excel Add-ins and click Go. This screen will pop up, maybe. Come on. Come on. There it is. Check the top two boxes and then click OK. And once again, data analysis will pop up. Now you have the data analysis tool. I'm going to do it again. File, Options, click on Add-ins, Manage Excel Add-ins, and then click on these top two buttons right here. Then click OK, and then the data analysis tool will show up. Stop sharing and go back to my other computer where it is much better.
Now, do you want us building these Excel sheets, or is the template available for the?
So in the assignment, when you click on the assignment, the template is there to download.
Okay.
Yeah, so it'll look just like this, except for it won't have the data in it. So your raw data, you should put it right here. You'll copy it and paste it, whatever. So the first thing I'm going to do, I'm not even going to highlight my data yet, and I'm going to click on data analysis. What I'm looking for, scroll down, scroll up. I'm looking for descriptive statistics. So that's what you want to click on, descriptive statistics, and then click OK. The input range, this is all of the things I want input in there. So I'm going to highlight everything. Highlight it all. Okay, and that filled the box in. Then you're going to click on this checkbox right here for summary statistics, because that's what I want. I want the summary statistics. Then the output range, I want it to end up in this box. I want it to end up in that box. So I just highlighted this whole box for output range. So input range is your continuous data. Output range is this box, and click on the summary statistics button. Then click OK. I'm going to make this bigger. There's all sorts of really cool stuff in here. We've got the mean, median, the mode, standard deviation, has our sample variance. We don't care about that. I don't care about kurtosis or skewness. It has my range, my minimum and my maximum. Tells me how many I have, adds them all together. I don't care about those things. Standard error is something we're going to do in chapter 9, so don't even worry about standard error. So while you're doing this lab, as much as possible, I want you to use the Excel tools, because the point of these labs is to use Excel. Let me show you how to use Excel to populate the cells. So for median, you click equal. You have to put the equal sign first, click equal, and then click on the box that has the mean and hit enter, and it will populate it. Same thing with standard deviation. Hit equal, and then click on the box that has the standard deviation and hit enter, and it populates it. I'm going to ignore number 2 for a second. For median, click equals and go up to median, hit enter. Same thing with mode. Mode, bam. For number 4, I don't want you using anything out of this box for number 4. I want you to talk about the fact, like for mine, my mean and my median are extremely close to each other. Therefore, the data is symmetric. It is not skewed, it is symmetric. If your mean is greater than your median or your mean is less than your median, you can talk about right skewed or left skewed. But I want you to compare the mean and the median and tell me how it's skewed and how you know. That's what I want you to do there. For number 2, this is asking if you have any unusual values. You need to use z-scores. There's 2 different ways to do that. You can either determine what your upper and lower boundaries are. So what value has a z-score of 2, what value has a z-score of -2, and calculate that and say, a z-score of 2 is at 6.8 and a z-score of -2 is at 4.2. Therefore, I have this value as an outlier. Or you can calculate the z-score of your lowest and highest value. Let me show you how I can do that using Excel. So if I wanted to do math, you always hit equal. I put parentheses, my first data value minus my mean divided by my standard deviation. I hit enter, and this tells me that this value right here has a z-score of -2.4. And I can do the same thing with my highest value. Then I can say, hey, that is an outlier because it has a z-score of -2.4. So you either find the z-scores of your highest and lowest values or find your boundaries where your mean is greater than median. I believe it's right skewed. So my mean is greater than my median. Yeah, okay. So there we go. So 5-number summary. Once again, use your tools. Hit equals my lowest value, my minimum. Same thing with the highest value. Let me show you how to get the quartiles. This is actually really cool. So equals, start typing the word quartile. Look at that. Click on that. And it tells you array and quartile. So highlight all of your values. So it is quartile. You click on the little button when it pops up. Okay, there's the range of my data. And I want the first quartile. So I hit comma 1 and then close my parentheses and hit enter. Quartile 2 is just the median. Quartile 3, once again, equals. Quartile, start typing it in and it'll show up the range of my data. I mean, the whole point is using the Excel tools. So I will be checking when you upload your Excel file, I will be checking that you're using the Excel tools. Equals my maximum. I think you get the idea. And then IQR. So you do equals, parenthesis. Actually, the parentheses don't even matter, but this one right here minus this one right here. Close my parentheses, hit enter. That's how you calculate the IQR. And then that's it. That's your assignment. Questions on the lab before we close out?
So for question 2, are we doing that for each data point or just the ones that are unusual?
I would say just do the highest and the lowest. This
Just
one
the
right
highest
here.
and the lowest.
Yeah,
So whenever we write that, like yours is a magnitude of 4.4 that you used, would you leave the answer -2.40?
I would probably type in here 4.4 has a z-score of -2.4, so it is an outlier. I would type something in
Okay.
so that I can see that you understand what it means.
Gotcha. Okay. Thank you.
No problem.
Uh,
That was a good
Can you,
question. Anyone else?
can you show me how to get this Z-score using the tools one more time?
Okay. So always hit equals. I put parentheses. I'm just going to pick any value. So pick a data value minus the mean. So I'm clicking on the mean. So I just clicked on a data value minus, clicked on the mean, close my parentheses, hit the divided by, click on standard deviation, then hit enter.
Oh, okay. I see what's going on. Okay, cool.
You just hit
Okay.
equal and basically you're typing in the math.
Gotcha. You're
Yeah.
just clicking on the appropriate cells for the.
Yes, exactly.
Gotcha. Gotcha.
All right. This is really going to help you all with your final project. I will probably give you guys your final project next week at some point. This stuff will help you significantly with that. Man, I feel so bad keeping you all here for 2.5 hours. This is the longest class we will have. None of the other ones are going to reach quite this late. So, if you all survive this one, you're definitely going to survive the rest of the term. So, anything else? We're still recording. I'm going to turn the recording off in a second.
I just got to get you after class.
Okay, I'm going to turn off the
I
recording.
have a